So I've been learning a lot about the different tools that Posit has come out with recently to programmatically interact with LLMs with R and Shiny. And so today I'm going to go through an example application where we use natural language to actually manipulate the visuals within the app and kind of toggle between manual traditional filters and a chat interface. So first, just a little bit of background info to give you some context into the data we're going to be looking at. Each year, CMS, the Center for Medicare and Medicaid Services, penalizes hospitals financially each year for having what's called excess readmissions. So a readmission is when a patient is admitted to the hospital and then they come back and are readmitted within 30 days. And so the accumulation of those over the course of the reporting period, which is usually 3 years, determines kind of how much reimbursement the hospital will receive from CMS for their Medicare claims. And so this program only applies to Medicare patients and only applies to these 6 different disease cohorts. So AMI, acute myocardial infarction, heart failure, pneumonia, COPD, hip and knee surgeries, and CABG surgeries. And so the way they do it, they look at all the readmissions and all the index hospitalizations over the course of this 3-year period, and they end up calculating what's called a predicted readmission rate and an expected readmission rate. And then they take the ratio of those two to turn that into this excess readmission ratio. Basically, the magnitude of that is going to determine how much of a financial penalty the hospital is going to get. And so it's capped at up to 3% reimbursement penalty, meaning that, say, a hospital has a 2% penalty due to this program. That means that for the now given fiscal year, when that penalty is in effect, all Medicare payments from CMS are going to be reduced by 2%. And so for big hospitals, these can add up to big chunks of money. And so readmissions is a big focal point for hospitals, obviously from a patient care perspective, but also from a financial perspective. These two components, the predicted readmission rate and the expected readmission rate, these are calculated not just from the raw data, but they try to risk adjust a hospital's rates based on that hospital's case mix to account for the fact that some hospitals just might see populations that are inherently sicker than others. Statistically, what is done here is they have a generalized linear mix model, a logistic regression model that adjusts for a bunch of different patient factors and covariates like comorbidities. They get an expected readmission rate, which is based on the average effect of all hospitals. And then the predicted readmission rate is this readmission rate adjusted for all of those clinical factors, but then where the individual hospital gets this random effect. And so the idea is that given your hospital's case mix, after adjusting for your specific population of patients, how much more likely is a patient to be readmitted by being treated at your hospital versus the average hospital? These 3 metrics, the excess readmission ratio, the predicted readmission rate, and the expected readmission rate, are the 3 main metrics we're going to look at within the application today. All right, so this is what the app looks like. I have it sitting on Posit Connect Cloud. I'm actually going to make it bigger, full screen, so we can see it a little bigger. So what we have here is a map of the state of Wisconsin with some different hospitals scattered throughout. Each dot on here represents a hospital. Kind of the color of the dot and the size represent kind of how much excess readmissions they have for the particular disease group that we're looking at. And so there's this hospital down by Milwaukee for AMI who had a predicted readmission rate of almost 17%. Their expected was only 14%. And so they probably got penalized in the program for having excess readmissions there. And then we have a graph down here showing the relationship between the predicted readmission rate and the expected readmission rate by the different cohorts, so we can kind of get a sense of what those distributions look like, and the expected readmission rate versus the excess readmission ratio. A few cards just showing some metrics about the hospitals we have selected, and then a data view to just see the line item information about what we have selected. First, to start, we have these filters and controls on the left side here, which are just filters that we would traditionally use. So we can select, we want to filter to a specific hospital. We can do that, and our map's going to update, our points are going to update based on the different hospitals we selected. And then we can come down here and say, okay, right now we're focusing on the AMI group. Maybe I want to look at heart failure, and the map's going to change and show all the hospitals that are participating or have metrics for the heart failure cohort. So here's where the cool part comes in. So I added this little toggle for chat mode, and when I hit that, I'm going to get prompted with just a little chat thing, and all of those manual prompts go away, and now I'm able just to chat with the app in natural language instead of using the filters, kind of start exploring the data that way. And so we might say something like, show me the hospitals with the top 5 largest excess readmission ratios across all diagnosis groups. And so it's going to do some stuff in the background, give me a message back, but you can see that it actually went and updated my map to some hospitals and updated all of my filters. So by just chatting with this chat pane here, this LLM, I'm able to actually manipulate the map and all the visuals to update as I'm just chatting with my data. And you can see here that it generated the SQL query, and this is kind of the magic behind the scenes, is that it's generating SQL queries on your data, which makes it really easy to fit in with your visual manipulation behind the scenes. And so we'll get into that a little bit later, but it's pretty cool, and we can start asking other questions, like for example, I'm just going to copy and paste some I had written down. Show me the hospitals that had excess readmissions for heart failure. And again, it's going to do some querying, and it's going to find some hospitals. And I said I wanted hospitals that had excess readmissions for heart failure. So if we come and look down here, we can see all of these heart failures, this orange group down here. All of these are above 1, and so we can see that it seems like the query got it right, and we can kind of explore and click on some of these on the map. So this hospital, Bay Area Medical Center, they had an excess readmission ratio for heart failure of 1.15. And so it seems like the queries are working pretty well. And kind of this is out of the box. I didn't really spend a lot of time optimizing the LLM component to like optimize the queries. So I thought it was really impressive what you're able to get kind of out of the box. And so we can go through a few more. So show me the hospitals in Marathon County that have more predicted readmissions than expected. And so it's going to find these 2 hospitals that we have in Marathon County. Okay, so Aspirus Wassa Hospital, for COPD, they had more predicted readmissions than expected. For Marshfield Clinic, for pneumonia, they had more predicted readmissions than expected. And so it looks like the query is coming through. If you look in this query it generated, it capitalized Marathon in my query, because in my data set all of the hospital characteristic fields are all capital letters, but I sent my query just in spelling Marathon County normally, and we're able to kind of prompt the LLM beforehand to give it a sense of what your data is, but it never actually looks at what your line item data is. It doesn't have access to your data, it just has access to your metadata, and then you can give it some descriptions and system prompts to clarify that, hey, all of my data is in capital letters, so when you write me queries to return data, you need to be mindful of that. You can say something like, which hospital had the largest discrepancy in predicted versus expected readmission rate for cabbage. And so now I'm just saying I just want like the name of the hospital. So I send that, and all it's going to do is return to me the name of the hospital. So in this case, Marshfield Medical Center, right in the chat pane. And so depending on kind of the question that you're asking, you might just be able to get the response about your data set right in the chat versus having it to go through and like update all your visuals. And so that's another pretty neat part of this. What is the average predicted readmission rate for each diagnosis group? And so it's going to correctly generate a query that's going to calculate the average by different diagnosis groups. And again, it's going to just return some results in the chat. So I don't actually have visualizations that are going to accommodate this format of a result. Here I have kind of specific visuals that I'm populating with my data sets. And so I can still ask these types of questions and get responses to them right here. And then finally, just another one that's going to manipulate some of the visuals here. So I might say, show me the top 10 best hospitals for knee or hip, and we'll see what happens. It doesn't really know what I mean by best. I never prompted or told it what I mean by best. That could be a subjective thing. What I really mean by best is, the ones with the lowest excess readmission ratio. And so it kind of guesses that that's what it is. And if you add more stuff into your system prompt, you might it might be able to just kind of know that if you define terms for it in the back end. But it's also kind of cool that it's going to ask you questions to clarify kind of what sort of definitions you're going to be using, so it knows what queries to actually write. And so I'm going to say yes, the excess readmission ratio. And so that I clarified it for him, it's going to then kind of know what I want and generate another query that's going to find the hospitals with the lowest excess readmission ratio for hip or knee surgery. So yeah, I thought this was a really cool learning experience to figure out how to integrate these two things in here, kind of having the chat option versus the manual filtering option and how they can play together, but really impressed by the tools that are out there to actually make this happen seamlessly. And again, all of this is done for free, even the deployment on Posit Connect Cloud. So next we're going to get into some of the code and what's happening actually behind the scenes in all of this. All right, so I'm in our studio, and I'm mainly going to focus on the code relevant to actually interacting with the LLMs and getting that into the app. But I'll just give you a kind of an overview of how the app's structured first of all. So I'm using the bslib package to drive the user interface components, and so I'm just building a sidebar page and then adding the sidebar, adding different UI elements to it, all my different inputs, and then using a leaflet output for the map object, and then I'm using the high chart framework for making the different plots. And so overall, the packages I'm using, besides Shiny, Tidyverse, bslib, are data mods is what helps me do the kind of dynamic simultaneous filtering of the hospitals, so that the different filters are updating in real time as I'm selecting other fields from that data set. The high charter package, leaflet, and then querychat is the main package we need for interacting with the LLMs and integrating the chat components into the app. The first part here, I'm just importing the readmissions and hospital data sets from the CMS website, and I'm just putting a GET request in and identifying and constructing the appropriate download URL and ultimately just importing it as a CSV file. And so if we look back at the CMS website, I'm just pulling in two files: the hospital general information file, which just gives hospital level data about the address, city, county, state, etc. for all the hospitals in the CMS database, and then this Hospital Readmissions Reduction Program file, which is going to show the metrics for the readmission program for each hospital in this long format. And so there's a measure column that indicates what the measurement is for. So readmission 30-day AMI, CABG, heart failure, hip knee, and pneumonia. And then we get the different metrics. So here's the excess readmission ratio, predicted readmission rate, and the expected readmission rate. And so in my code here, this PDC read function is just letting us use the identified dataset ID, which when you're on here, you can just find in the URL. Once you are navigating on the website and find a dataset, it's going to be this little ID up here. And so with this PDC read function, we can just paste this into the first argument, and it's going to go out and fetch that data set for you and give it to you in a nice CSV format. And so we can run that. So if we look at hospitals and HRRP, those are just those data sets imported directly from the CMS website. And so the next number of steps here are just building the base map for the state of Wisconsin in the leaflet framework. And one thing you'll notice on the app is that the actual precise location of hospitals isn't where their actual address is. I'm just using the zip code because that's what's available in these CMS files for simplicity. And so I'm just finding the centroid of the geometry of the zip code and just plotting a hospital at that point. And then I'm adding a little bit of random noise to the actual latitude and longitude plotted so that if two hospitals are from the same zip code, they're not going to be plotted directly on top of each other. So they're not going to be in the precise location on the map, but they're going to be in the general vicinity. And then just some cleanup with these data files I'm importing. And then my kind of master data set that's going to be worked into all the visuals and the chat component is this master dat object. And this is just really all of the hospital information joined into this long formatted HRRP file. And so I just kind of have all the data in one data frame, parsed out for cleanliness, but kind of each hospital is going to be found on multiple rows, one row for each of these diagnosis categories, and then a column for the excess readmission ratio, the predicted readmission rate, and the expected readmission rate. And so that's kind of the main data frame I'm feeding into everything. So here we're just constructing our base map and a color palette, and those things are going to be fixed for the app, and then within the server we're going to use those components to just update what's needed, so we don't have to re-render the entire app. Or the entire map. We're just going to change the points using the leaflet proxy. Okay. So the first step with using querychat is going to be using this querychat _init function. And there's a GitHub repo that has the package in here. And there's a R version and a Python version, and it's within the Posit dev account on GitHub. But basically we initialize this query chat and we feed it a data frame. So here I'm just feeding it my master data set, and I'm supplying this table name, which is just going to be how the table is referenced in the SQL queries that get sent back to me in the chat. And so just looking at some of the documentation here of what is actually done behind the scenes with query chat, it's a pretty clever way to do it in that your actual data is never touched by the LLM. All it's going to do is basically send metadata to the LLM when you run this query chat init function, and then it's going to kind of get attuned to some distributional aspects or the names of your columns and kind of understand the general structure so it can be able to easily generate queries for you. But it doesn't need to actually have access to the raw data itself. And so that's what they say here. querychat does not have direct access to the raw data. It can only read or filter the data by writing SQL select statements. And so it's a clever way to take advantage of the power of LLMs in that it can be really good at writing SQL queries. And so it's easy for us to then translate the natural language prompting to these SQL responses. So a few other things about initializing this. So we supplied the data set, gave it our table name that we want to appear in the queries in the chat. So the create chat func is where we're going to specify the LLM provider that we want to use. And they give you documentation of how you do that here. But this is just coming from the ellmer package. So if you haven't heard of the ellmer package, it's kind of the driver behind what allows you to chat with and interact with LLMs with R. And so they have all these different models that you can connect to, and then you need to supply your different credentials and everything. And so you can see I'm using Chat Gemini. So I chose to use Google Gemini here, and it looks like they must have updated the names of the function since I last installed ellmer. But I'm using the Gemini LLM because I've used it a few different times, and you can make a free account on the Google Gemini API. You can make a free account, and then you can get a API token and configure that, and they give you a generous kind of free tier. The other things you have to set up payment right away, and so I just wanted to use kind of a free model that was available. And they actually tell you in the documentation which LLMs are preferred. And so they preferred OpenAI's GPT-4o or Claude Sonnet models. And so ideally, those are probably the ones you would use, but Gemini, it actually seems to work reasonably well and obviously works fine for demonstration purposes. And so to actually set this thing up, we're telling it what chat provider we want to use here, but behind the scenes, you need to have your Google API key generated. So on your Gemini account, copy your API key, and then you can just open your R environment file, and then you would just paste it up here. So then the next piece is you can add a greeting. So this is just going to be what the initial prompt says when you see the chat or initialize the chat. It's just going to say, ask me a question about the HRRP in Wisconsin. And then the other very important piece to this is this data description. And so you've probably heard of a system prompt, and it's basically orienting the LLM to be attuned to kind of how you want it to behave or what you want it to know in the responses it gives. And so they made this really simple to be able to supply a file and that is basically going to just give all the description that you want it to know about the data set you're providing or any context or anything like that, so that it knows those things as it's generating queries for you. And so they say here in this data description section, if you give querychat your data set and nothing else, it will provide the LLM a basic schema of your data. So it'll give the column names, it'll kind of give the data types, and maybe some distributions or ranges, and a few different choices for some text columns. But you probably want to tell it more than that. And so you can just supply like any sort of markdown file that gives definitions of columns or anything else you want. And so I put together a file that I kind of just wrote out in more detail some of the things about these data sets I'm working with and what things mean. And so I just made a markdown file that gives a description of where this data was from, what the goal of this program is, the different cohorts, kind of this key value pair thing to indicate what these abbreviations actually mean, so that the chatting actually can handle, mapping. If I write out acute myocardial infarction, hopefully it'll then know that I'm talking about AMI, and it'll filter the data appropriately. Links to some data sets that I use, and then some more specific definitions of some of the columns that I'm using. And I added this important note in the description, which was actually noticeably important. And it was because in the raw data file, when we're identifying a hospital, everything is in capital letters, so like the city and the county. And if you're just writing like a general request to the LLM, and I say show me records for county X, it's not going to just automatically know that everything's capitalized in the fields for that county. It's just going to kind of put the case based on how you ask the question. And so once I actually had this important note in here to say that everything is capitalized, so when you're writing queries, you need to capitalize these things to make sure it actually accesses the right rows of the data, that actually works. So then once I started asking for things, didn't matter kind of if I capitalized the first letter, all lowercase, whatever, it would appropriately write the query in with all capital letters and find the right rows. Where before, when I didn't have that, it wasn't actually giving me the right results. So that was a really important piece to figure out here. And then I gave a few descriptions of the different measure categories that I'm using, so that when I'm talking about like excess readmission ratio, I can kind of talk about, I want hospitals who have excess readmissions, or maybe kind of use slightly off phrases. It kind of has some context of what I'm talking about based on this description. So I thought supplying this data description and being very specific about things really actually made a difference. And so we supply those things and we configure our query chat, and that's kind of set up. And this is in our global.r file. So this is just going to run once when the app launches, and it's going to be kind of used throughout the duration while the app is running. So then in the UI file where the query chat comes into play, you remember from the app, it was just that one chat pane that was really the actual user interface that you're interacting with when you're using the app. That's just going right here. And so I have it in this conditional panel. All I'm saying is the condition is if that chat mode toggle is turned on, and if it is, then it's going to show this chat user interface. And all this is query chat underscore UI, and that's what builds you the chat UI. There's also a query chat underscore sidebar function, which will create like a nicer looking and complete sidebar for your chat. Otherwise, you could just insert this UI wherever you want it in your app. But that's really all you need in the UI file to create your chat user interface. For my specific app where I want to toggle between manual filtering and chat input, the conditional panel worked out well. And so I have the traditional filters are also in a conditional panel, and they're just saying if it's not in chat mode, show this. If it is in chat mode, show the chat pane. Everything else related to manipulating the visuals changing things dynamically with the chat response and everything. The rest of that is all handled in the server. So you need to, somewhere in the server, just create this querychat server object, and you're going to supply it that configuration that you made in the app initialization in the global.r file. And this thing is going to be where you're going to continually reference as you go and execute. And so what I'm doing here to make this work is I'm basically just saying, if I'm in chat mode, I'm going to take the current data frame from the query chat, and that's accessible through this query chat, the df component of this query chat object I made here. And so basically in this query chat server, there's always a data frame that's kind of the current data frame being returned by the chat. And so that's what I'm accessing here, and it's just going to change every time I enter a new prompt, the current state of that data frame. And if I'm not in chat mode, then I'm just applying my manual filters like I normally would. So now this current hospital's reactive object is going to either contain a data set derived through the filters or through the query chat, and I'm just going to be working with that reactive data set for my different visualizations. So then when I create the map, I just have this one leaflet section using the leaflet proxy just to update my points on the map, and I'm just feeding it my current hospital's data set, and it doesn't care whether it came from what was generated from the query chat or from the manual filters. It's just taking whatever data is there and plotting the points on the map. And then for the scatter plots that are shown, it's the same thing. We're just pulling in the hospitals that are in the current list of selected hospitals and showing some plots. And then kind of the same story throughout all the visuals, just taking the value of the current hospitals and putting them into the visuals. And so really, there's not a lot of complexity to getting the data from the LLM into the visuals. It's really just kind of understanding or expecting how the data is going to be returned from the query, being careful about kind of what your data set looks like that you're entering into the LLM, giving it the proper instructions so you can know what kind of queries it's going to write, kind of anticipate the format of the results and the data frame that's going to be stored in the chat at any given time. And that's basically, and then you can just kind of build your visuals based on that.